I spent a day reading about shared components, and one thing decided it for me. You add the feature, and it delivers exactly what it promises. A chunk where every entity in it uses the same mesh, grouped for you, for free. Then you go to actually draw those entities, and you find you still have to gather them and pack them before a single byte reaches the GPU. The pass it was supposed to save you is still there. That's why Xynok ECS doesn't have shared components. Start with the gap the feature is trying to fill. An archetype in this ECS is defined by a set of component types. Types, not values. So an entity holding a cube mesh and an entity holding a monkey mesh have exactly the same components on them, transform and render mesh, which means they land in the same archetype, in the same chunk, sitting right next to each other. ECS gives you type grouping and nothing else. What a renderer usually wants is value grouping. Split these apart by which mesh they actually point at. A shared component is how Unity closes that gap. You mark one component as shared, and its value gets lifted out of the entity rows and stored once on the chunk itself. Every entity in that chunk implicitly has the cube mesh, and none of them carries a copy of it. Two things fall out of that. You stop duplicating the value across 10,000 rows, and the chunk boundary starts meaning something new. It's now a group of entities that share a value, not just a group that shares a shape. But after a day of digging, I don't think deduplication is why anyone actually wants this. The thing you're deduplicating is a handle, a few bytes. The real reason is rendering. If you have 10,000 cubes and 10,000 monkeys on screen, you want to submit each group as one batch, not 20,000 individual draws. Shared components hand you those two groups already separated, at no extra cost, because the chunk boundary is the group boundary. That's a genuinely good idea, and it's the reason the feature exists. Now the price. A shared component still has to behave like a component. You can add one, you can remove one, you can change its value. And every one of those is a structural change, exactly like the ones from last episode. The entity's row gets copied into a chunk under a different archetype and swap removed out of the old one. Except now, an entity can be forced to move, even though its component set never changed, purely because a value changed. Every structural change path in the core has to learn about a second kind of thing. Here's where it stops paying for itself. Say 10,000 entities share the cube mesh, and shared components have grouped them perfectly. Every one of them sitting in a chunk keyed to that mesh. Knowing which entities share a mesh is not the same as holding something you can upload. What actually goes down to the GPU is per instance data, transforms, one after another, in a contiguous buffer. Those 10,000 entities are spread across many chunks, and what you read out of them is not one continuous run. It's fragments, in whatever order you happened to walk. So if the CPU is the one collecting objects to render, you need a pass regardless. Walk the matching entities, pull their transforms into a packed buffer in the order the GPU wants them, and then upload. Grant that the ECS carries shared components perfectly, and that pass still exists, and it still touches every instance. The feature shortens the first step, finding the right entities. It cannot remove the second step, and the second step is where the work is. The thing that convinced me I wasn't just rationalizing my way out of the work is Bevy. It's one of the most actively developed engines around right now, and it has no shared components at all. A mesh reference there is an ordinary component sitting on the entity, and inside it is a handle, an ID that points at the real asset in the asset store. No special kind of component, no second structural concept in the core. And it renders fine, because the batching logic lives where the batching problem lives, in the renderer. So this is where I landed. When you do need entities grouped by the value of a component, build an index that does exactly that, owned by the system that needs it, sitting beside the ECS rather than inside it. It can be rebuilt, it can be cached, it can even be a frame stale, none of which is true of something wired into your archetype layout. ECS is fast because it's simple, a set of types packed into a chunk. Classification is a systems job. Use what the ECS is good at, instead of spending its core on convenience.